Hello guys, lecture 8 is on vectors, matrices and linear equations. So basically this is an introduction to vectors, matrices and how we can use those to solve linear equations. So what is a vector? So a vector is a variable with both magnitude and direction. Remember that from your physics course. So we have got vectors with one dimension or one dimensional array of numbers. For example, we have got row vectors. So this is a row vector, and then column vectors. So column vectors, so these are column vectors. So under column vectors, we have got identity vectors. So identity vector E1, just an example where E is on the first element on the first row, E2, E3, and so on. Take note with identity vector, they consist of binary digits 0 and 1 only, and the 1 is on the if it's E2, the 1 is on row 2, E3, the 1 is on row, E4, the 1 is on row 5. Those are column identity vectors. Then we've got different types of matrices, two-dimensional array matrices. We have got a zero matrix. So this one is two-dimensional. So this has got zero matrix contains all elements are zeros for a zero matrix, and then we've got an identity matrix for a 2 by 2 or a two-dimensional array matrix. So for this one, you have got your ones along that diagonal. So it, if you have got non-zero elements which are on the middle slanted row like that as shown there, we call this a diagonal. So all these elements that fall along this line or this region, we call them a diagonal. So in an identity matrix, your diagonal contains 1, then the other elements are zeros. So this one is an example, a good example to illustrate how or what we mean by a matrix and a diagonal. And then if we say it's tri-diagonal, we mean that the matrix have got three slanted uh, slopes of elements. For example, you have got one, you have got the middle diagonal, which is the diagonal, and then the other one, this one, and then you have got this one. So this one is tri-diagonal, where other elements are zeros. All right, so then we've got a symmetric matrix. A symmetric matrix, all the elements that do not lie on the diagonal are the same. For example, you have a 5 here, you have got a 5 from both the upper triangular and the lower triangular. This one minus 1 is symmetric to this one minus 1, this one and this one. So every element that does not lie on 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 the diagonal is on the other side. So you can think of a diagonal as a mirror line where every element from this side is reflected on the other side. So a diagonal, can think of it as a mirror line. And then we've got a matrix that we call an upper triangular. So an upper triangular, all the elements will fall from the diagonal, forming up a triangle, upper triangular. So the elements will be on the top part of the diagonal of your mirror line. So the other part, the bottom part of that diagonal will all consist of zeros. So we call this a type of a matrix, an upper triangular matrix. Right, this is interesting. Uh, so far we know how to compute determinant of a 2 by 2 matrix. So how do we compute the determinant of a 3 by 3 matrix? So you see that this is a 3 by 3 matrix and you want to compute a determinant for this one. So the first thing that you need to do there is to choose your column. So if we are going to use elements from this column, you will see that if I choose the 2, so this column will start with 2. So this is what we'll do. So I'll just, what I'm doing there, you just close all the element, or you just close the row and the column that contains the element that of your interest. In this case, it's 2. And then you remain with this matrix. So this will be 2. And then determinant of the matrix that remains. In this case, is 0, 5, 5, 4. So that will be your first element. The second element, this one is the second element is 1. But for the second element, we always subtract. So you put a minus sign, you put that element which is 1, and then you close all the rows, the column that contains that element and the row that contain that element. So if you do that, you remain with the matrix 3 minus 2, 3 minus 1, sorry, 5, 4, 5, 4. And then the next element will be minus 1. This one, minus 1 here. So that minus 1, you put it there. Then you close the column that contains minus 1. And then you close the row that contains minus 1. And then you remain with the 2 by 2 matrix. 3 minus 1, 5, 0, 5. So that's how we reduce this to 2 by 2 determinants. So if you do that, you obtain the determinant of this 2 by 2 will be 0 minus 25. So this is minus 25 times 2 minus, remember this minus, this one is a plus, minus, plus. This one will always carry a negative sign. This number, this number will always carry a negative sign. And then the determinant of this matrix will be 3 times 4, 12. This times 1 minus 5 minus 1. So this is 12 plus 5. So which is 12 plus 5. And then the determinant of this one is minus 1. 3 times 5, 15. 0 times 1 is minus 0 times 1 is 1 is 0 minus 0. So the determinant is minus 82. So that's how we compute determinants for matrices of dimension 3 and above. All right, so now how do we add matrices? So matrix addition, if you have got two matrices A and B and you want to add them, this will be, you can only add this if they've got the same size. So you can only add the matrices if they've got the same size. So if you have got matrix A and B and you obtain matrix C, with the same size as A or B and B. So you will discover that I represent rows, J represent columns. So for you to get the IJ element, you'll add an IJ element from matrix A plus an IJ element from matrix B. So we are adding elements in the same row, same column together to get an element in the same row, same column in C. Matrix multiplication. If you have got matrix A of dimension nm and matrix B of dimension pq, it is only possible to multiply these matrices if m is equals to p. So if m is equals to p, then you can multiply these matrices where each row in matrix A will multiply each column in matrix B. So each row multiply each column on matrix B. So represented by this formula. So we can use matrices to solve systems of linear equations. So for example, if we have got this system of equation 2x 4x2 minus 3x cubed is equals to 3, 2.5x1 minus x2 plus x3, x3 is equals to 5, x1 minus x2 minus 6, x3 is equals to 7. So this is the standard form. Make sure you write this such that the x1 are on the same column, x2 is on the same column, x3 is on the same, so that you avoid confusion. You can transform this to matrix form by taking the coefficients of the variables x1, x2, x3. So this will be given by this matrix times x1, x2, x3. Remember, we said matrix multiplication is a first element will multiply first element on the column. Second element multiply second element on the column. Third element on the column. So this is how we transform matrices, standard form equations to matrices. So the solution of this matrix is as follows. So x1 is a column vector, x1, x2, which is 1 and 2. So you can solve this using matrices and get the solution. There are some systems of equations that do not have solutions, and these equations are said to be inconsistent. So system that does not have solution like this one is said to be inconsistent. A good way to observe this type of system is that they are written as multiples of the other. For example, if I multiply this equation, I'll get by 2. I'll get something similar here. So if this is 2, 2x1, 4x2, so it's almost the same except for this part. So if you have got such a case, then it's difficult to get the solution. So the equation are said to be inconsistent. And then some systems of equation may have infinite number of solution. So some systems may have a number more solutions, more than one solutions. So many solutions like the one that we saw above. So most of these inconsistent systems, they give us infinite number of solutions where you just have to take one of these variables and then just make x the subject of the formula, maybe say x1, and then x1 represented in terms of x2, then you can then substitute x2 to be some other variables, say a in that case. And then you can also solve systems of equation using a graph. So if you can draw this line x1 x2 is equals to 3, and then you also draw this line, so where those two lines intersect, that will be your solution. So where these two lines intersect, that will give you your solution, provided they say this is x1, this x is x2. So thank you.